Okay, in this video we're going to cover section 6.1, right triangles. These are all applications. This really should be a review of all the stuff we've already done. Just make sure you know this information here. Angles of a triangle always add up to 180 degrees. Pythagoras identity, we've already worked with that quite a bit. And then all of your SOHCAHTOAs and the reciprocals of that, okay? We're going to start with number 1, solving the right triangle. Round the lengths of the sides to 1 decimal place, okay? So what we're going to do is anytime it says solve a right triangle, you're looking for all of the angles that we don't already know, or sides, okay? When we label a right triangle, the angles are going to be a capital letter. So here we have A, B, and C. Typically, C is going to be assigned to the 90-degree angle, okay? A and B are going to be opposite sides of the angle. So if angle A is here, opposite is little a. Angle B, opposite, little b. C, 90 degrees, that's going to be our hypotenuse. All right, so let's go ahead and solve this. So we can easily find angle B. So I'm going to start with that. I'm going to say angle B is equal to 180 degrees minus 28 degrees minus angle C, which is 90 degrees. Use your calculator to solve that, and you should get 62 degrees. So angle B is going to be 62 degrees. Okay, I'm going to go ahead and label that here, just like that. Okay, now we need to find sides A and B. Here you can use angle A or you can use angle B because angle B is an exact value. I typically will tell students use what is given, especially if it's decimal places. So I'm going to be using angle A. If I want to solve for the opposite and I'm given the hypotenuse, we should use sine. We're solving for opposite and we're given the hypotenuse. So I'm going to use sine of A is equal to opposite over hypotenuse. Let's fill this in. Sine of 28 is equal to opposite, which is little a, over 14.8. If I want to solve for my little a, I have to move this 14.8. So I'm going to multiply 14.8 to both sides. So those will cancel out. Make sure your calculator's on degree mode, and we're going to go ahead and start with the 14.8 sine of 28 degrees. When I press enter, I get A is equal to 6.9. Okay, and just leave it to 1 decimal place. In order for me to find B, I can solve it 2 ways. I can use another identity listed here, or we can use Pythagoras theorem. I'm going to go ahead and use the other identity because this is an approximation. I'm going to use angle A again, but this time I'm trying to find the adjacent, and I'm given the hypotenuse. I try not to use the variables that I actually found because those are going to be approximations. So here we can use cosine. So I'm going to say cosine of A is equal to B over H. So let's go ahead and plug those in. Cosine of 28 degrees is equal to B over 14.8. Again, I'm multiplying both sides by 14.8, and I'm going to get B is equal to, I'm going to use the approximation, B is equal to 14.8 cosine of 28. Okay, that will be 13.1. Right? So we have our 3 values that we find. I'm going to put the answers all here. So we have B is equal to 62 degrees, A is approximately 6.9, and B is approximately 13.1. Again, we're solving. We're doing this exactly the same way. However, notice this time we're only given 2 sides. We're not given the other 2 angles. Okay, first thing I'm going to do is use Pythagoras identity and solve for B. So A squared plus B squared equals C squared. A squared is going to be 9 squared plus B squared is equal to 20 squared. So B squared is 20 squared minus 9 squared. Okay, and I'm going to use the calculator for that. 20 squared minus 9 squared, and I'm going to get 319. So B squared is equal to 319. So B is equal to positive square root of 319, which is going to be approximately 17.9. We're rounding to one decimal place. All right, to find the angles now, what we're going to do is we're going to see what we have. Let's solve for A first, okay? So if I'm doing A and I'm given the opposite, I'd rather use the opposite because that's actually given over hypotenuse, we're going to be using our sine value. So I can say sine of A is equal to opposite, which is 9, over hypotenuse, which is 20. Now I can say A is going to be equal to the inverse sine of 9 over 20. This is already going to be in the correct quadrant. We're just doing quadrant 1 because sine is positive, so all I'm going to do is just plug this into the calc. It doesn't say if this is looking for radians or degrees. We'll just go ahead and keep it in degrees. Okay, so I'm going to do second sine 9 divided by 20. Keep it in degree mode. Okay, and here we get A is going to be approximately 26.7 degrees. Okay. For B, what we can do is we can use the cosine value, or we can go ahead and solve for angle B. Remember, angle A plus angle B plus angle C always has to equal to 180 degrees. So I can plug in what A is, which I have as 26.7, plus B, we don't know, plus C, which is 90 degrees, and just solve it like that. Okay, so 90 plus 26.7 is going to come out to B plus 116.7 is 180, and then subtract on both sides. And I get 63.3 degrees. And this is an approximation as well. Okay, and there are your solutions. All right, next problem, number 3. Here we go. Now we're going to work a little bit, and we have to create our own triangles. This shouldn't be too difficult, but you just need to keep everything straight. And always, I recommend drawing your picture. All right, number 3, it says, a survey stands on ground level 100 feet from the base of a lighthouse. So we're going to have a survey right about here. Okay, this distance here is going to be 100 feet. He measures the angle from the ground to the top of the lighthouse, so from here to here, is going to be 18 degrees. Round to the nearest foot, what is the height of the lighthouse? So what we're looking for is H. Okay, so here we're given an angle, we're given the adjacent, and we're looking for opposite. So tangent of 18 degrees is equal to opposite, which is H, over adjacent, which is 100. I can solve for H by multiplying both sides by 100. Okay, so H is going to be approximately 100 tangent 18. H is going to be approximately 32 point, it says round to the nearest foot, so we're going to keep it at 32 feet. Okay, and that's it for that problem. Right? Number 4 says a survey stands at ground level 90 feet from the base. So here we're going to have 90 feet, this distance. It says here he measures the angle from eye level to the top to be 28 degrees. So I'm going to go ahead and draw to the top, and this will be 28 degrees. if the survey's eyes are 5 feet from the ground, what is the height of the entire lighthouse? All right, so let's go ahead and start here. We're given this angle. We want to find the distance from 5 feet above the ground all the way to the top of the lighthouse, which is our opposite, and we're given also the adjacent. So we're going to use tangent. Tangent of 28 degrees is equal to opposite. I'm going to call this distance here, I'm just going to call it x. Okay, x over the 90 feet here. Okay, again, what we're going to do is multiply it by 90 on both sides so we can isolate that x. Use the calculator. 90 tangent 28 degrees, and that gives us x being a distance about 47.9 feet. Okay, so now we have 47.9 feet, which is approximately going to be, we're rounding to the nearest foot, that will be 48 feet. But we can't forget to go back and add the 5. So the height of the lighthouse would be 48 plus 5 feet. In other words, about 53 feet. All right, let's go on to number 5. These are the ones that are a little bit more complicated. What we're going to be doing here is breaking the triangles up into 2 different parts. Okay, let's start with this one. It says, to determine the height of the window in the top of the lighthouse, 2 measurements are taken from the ground, 90 feet from the base. So both of these distances are 90 feet from the lighthouse. Okay. The angle of elevation from the ground to the bottom of the window, which is this black line here, this angle is going to be 36 degrees. Okay. The angle from the elevation to the top of the window is going to be 42 degrees. So I'm going to label that with my red pen since this is a red line, and I'm going to do 42 degrees. All right. It is important that what you should do is keep organized, and I'm going to draw the 2 triangles separately. I'm going to draw a triangle here that represents the bottom of the window. So 36 here and 90 feet here. Then I'm going to go ahead and draw the higher triangle, which is 42 degrees here, and it's still 90 degrees here. So I'm just keeping these organized. They're both right triangles, so we're going to be able to use the SOHCAHTOA. Okay, now what I'm looking for in this case, and I'm going to call this Y1, and I'm going to call this Y2. I'm going to look for the opposite of both of these, and then what we're going to basically do is subtract the difference. Okay, let's start with this one first. Opposite over adjacent, we're still using tangent. So I can say tangent of 36 degrees is equal to Y1 over 90. Okay, again, multiply by 90 to both sides. So Y1 is equal to 90 tangent of 36, or approximately 65 feet. I'm only rounding to the nearest foot, so I'm going to go up. Y2 is going to be equal to, again, use tangent. This time it's 42 degrees, Y2 over 90, and we're going to multiply both sides by 90 again. So Y2, all I'm going to do in my calculator is change the angle to 42. Here we get 81 feet. Okay, so if we have the first height to be 81 feet and the second height to be 65, we can find out what the height of this window is. So our window will be equal to 81 feet minus 65 feet. So the window would be equal to 16 feet, and that will be our answer. Number 6, last problem. Here it says an observer in the helicopter hovering 200 feet above the sea. So this distance above is 200 feet. makes a measurement of two buoys at point A and point B. She finds the elevation of depression to be, from angle A, this is going to be 44 degrees. And from angle B, it will be 35 degrees. These are alternate interior angles, so this angle here will also be 44 degrees, as well as this angle here would be 35 degrees. Okay? Assuming that the observer in the same vertical plane as the buoys, what is the distance between the two? So what we're looking for is we're going to find this distance independently from this distance here, and what we want is the total distance. Okay? Let's call this x1 and let's call this x2. Let's start solving with x1. And we're also again rounding to the nearest foot. So here I'm given this angle, opposite over adjacent, we're still using tangent. So I can say tangent of 44 degrees is going to be equal to 200 feet over x1. Now in this particular case, the variable we're solving for is in the denominator, whereas in previous problems the variable was in the numerator. So what we can essentially do here is flip the variable with whatever is on the other side of the equal sign. So x1 would be equal to 200 feet divided by tangent of 44. And basically all I'm doing is multiplying by x1, but then I have to go back and divide by tangent of 44. So you're going to get that exact value. Okay, let's go ahead and put that in the calculator. So I'm going to do 200 divided by tangent of 44. Okay, x1 is going to be approximately 207 feet. x2, we're going to do the same thing. We're going to use tangent of 35 degrees is equal to opposite over adjacent. And then again, you're going to flip. So x2 would be equal to 200 feet divided by tangent of 35 degrees. All I'm going to do is change this angle in the calculator to 35. So now I get x2 to be a distance of 286 feet. Okay, if we're rounding up, we need to round this one up since it's greater than 5. So the distance between the two buoys is all we're going to do now is just add those two. 207 plus 286. The distance is going to be equal to 493 feet. And that's the end of this section. Let me know if you have any questions.